Hello dear students, I welcome you all to the video lecture on the topic solids. I am Dr. Smita Pimple, Professor, Pharmaceutics Department at Modern College of Pharmacy, Nigdi, Pune. Students, we learned about certain definitions, basic classification in crystalline amorphous form for solids. Then we studied some definitions, crystallization process in 3 steps, that is supersaturation, nucleation and crystal growth. We studied about the brevis lattice structures based on lengths across 3 axes ABC and interfacial angles alpha, beta, gamma and different crystal habits. Today we are going to study about polymorphism. Polymorphism is the ability of solid materials to exist in 2 or more crystalline forms with different arrangements or conformations of the constituents in the crystal lattice. That means the material is same, molecular formula is same, but the molecules, they will place themselves in different positions so that they are forming different crystal lattice structures, and because of this the material can exist in different forms. This is referred as polymorphism, and the different forms, they are referred as polymorphs. So this is also true with various API drugs or excipients also, and we need to study those because due to polymorphism they exhibit different properties, and this is the thing which we should be concerned about. Now, pseudopolymorphs, these are different crystal forms. They have molecules of the same given substance, and they also contain molecules of solvent incorporated into a unique structure. That means, suppose you are crystallizing a particular solute from aqueous environment, like if you are using water as crystallizing solvent, then it is referred as a hydrate, because some molecules of water, they are entrapped into the lattice structure of the solute or the matter. And if the crystallizing solvent is any other organic solvent, then it is referred as a solvent. Now we are going to see some examples for polymorphism. So chloramphenicol palmitate, this is a drug which exists in 3 polymorphic forms A, B, C. Out of these 3 forms, stable form is A, metastable form B, and unstable form is C. So the form B, it dissolves faster than form A. It has a much higher solubility. Low serum levels for the stable polymorph A were observed. Then another example for polymorphism is carbamazepine. 4 anhydrous polymorphs you will get, which are named like Roman number 1, 2, 3 and 4. And the study reveals that the initial dissolution rate of carbamazepine was in the order of form 3 is having highest dissolution rate, then second form, and then the dihydrate form of the drug. While the order of area under curve values, you will get like form 1 highest, then form 3, and then the dihydrate form. So this difference is due to the rapid transformation of form 3 to dihydrate in the gastrointestinal fluids. So what we can conclude from such studies is that the polymorphic forms, they exhibit different solubilities, different dissolution profiles, and this will lead definitely to getting or exerting therapeutic effects to, or pharmacological effects to, different extents. So this is very important with respect to drugs, that we need to study polymorphism before we figure out any particular polymorphic form to be added to a certain formulation. And these all studies related to polymorphism, it is carried out at the pre-formulation stage only. So I will advise your students, you just find out the different examples for polymorphism in pharmacy, maybe for certain excipients or certain drugs, and find out the metastable forms, stable forms, or different properties. Like I have prepared this table, like it is mentioned the drug, their polymorphic forms, and the properties which are uh, affected by means of polymorphism. So likewise you can prepare a table, and different examples you can collect for this studies. Polymorphism is very important and it needs to be detected. So the detection techniques are very important while carrying out the pre-formulation studies. Now I have listed here different techniques with which you can detect polymorphism. The most widely used method to detect polymorphism in drugs is powder X-ray diffraction, which is in short form it is called as XRD, or single crystal XRD. Then thermal analysis, that is differential scanning calorimetry or DSC studies, thermogravimetric analysis, that is TGA, infrared Fourier transform infrared FTIR spectroscopy, Raman spectroscopy, then solid state nuclear magnetic resonance spectroscopy, and optical and electron microscopy. And from these different methods, we are going to study in detail powder X-ray diffraction, that is XRD, and single crystal XRD in detail. You have uh, this method in syllabus to study in detail. Here we are going to study about the Bragg's equation, the derivation for the equation, and the instrument like rotating crystal method and powder X-ray diffraction. But even though only one method we are going to study in detail, I will very briefly explain the principles behind these different techniques. So students, in case of powder X-ray diffraction, the crystalline materials, they used to give characteristic X-ray diffraction patterns, and based on these peaks in the X-ray diffraction patterns, we can identify the polymorphs depending on the position and the intensities of the peaks. Single crystal X-ray, here we need to isolate a single crystal, and the diffraction pattern, it gives us information about the different molecular groups or the particle positions in the crystal lattice structures. Then in thermal analysis, the differential scanning calorimetry, this method measures actually the heat gain or lost by the system, and which brings about certain the physical or chemical changes within the sample, like it can be dehydration initially, that is losing the water of crystallization or the solvent molecules of crystallization. Then they may show the endothermic peaks for melting processes, or you can see the even decomposition if happens at higher temperatures. It can be seen with the differential scanning calorimetry. Then differential thermal analysis, that is DTA, it is based on monitoring the differences in the temperature between the sample and the reference substance. This is the difference is plotted as a function of temperature, and here you can study different processes like the boiling, sublimation, or vaporization, or changes, transitions in the solid states, or water loss. These can be studied with the help of DTA, where you are monitoring for whether the changes are giving you endothermic or exothermic effects. Then thermogravimetric analysis. This technique measures changes in the weight of sample as a function of temperature over a certain period of time. Then next, Fourier transform, that is FTIR spectroscopy. Raman spectroscopy and solid state NMR. These are spectroscopic methods to determine the polymorphism. And then optical and electron microscopy. In electron microscopy, there is scanning electron microscopy, that is SEM. So optical microscopy, it usually determine optical properties like indices of refraction, dispersion colors, and other morphological properties, or actual crystal habits for the crystals. Then scanning electron microscopy, it is a very useful method because it can actually determine the surface topography and the type of crystals and the crystal habit in polymorphism. So students, this is all about different detection techniques which can be used to study different polymorphs. This particular phenomena of polymorphism is very much important in studying the drugs and excipients. These difference in polymorphic forms creates a lot of trouble otherwise if not studied previously. So different polymorphic forms, they are differing in various properties, physical and chemical properties. So they may have different solubility and dissolution rate profiles. Their packing properties may be different. Their thermodynamic properties, like their melting or the vapor pressures, they might have different values for these. Their spectroscopic properties are also different, because of which we can use spectroscopic methods to distinguish between different polymorphic forms. Their surface properties, their interfacial tensions, they might be different. So all in all, if you won't study this, then there can be problems with their dissolution rate, solubilities, and this may lead to ineffective therapeutic benefit. So it is always essential to pay attention before going for formulation studies, that whether the drug or the components which are used in formulation, if they do have any polymorphic properties, and the stability profiles must be studied to ascertain that there is no polymorphic transitions occurring after the dosage form is finally going on shelf. And because such changes may lead to stability problems or therapeutic benefit problems, like they may not be eliciting a desired therapeutic effect if there are certain transitions related to polymorphism. So this is all about, students, and I hope you will be studying different examples of drug under polymorphism and their effect on the bioavailability. Thank you, students, for watching this video patiently. Bye for now. See you in the next lecture.